So welcome to the Saugus Ironworks National Historic Site.
It's a big day for the 5th grade at Ferryway School, just outside Boston.
What's this simple machine right here? Wheel and axle, right.
This field trip is the highlight of a 6-week project that integrates science.
This works like a lever, compresses the bellows closed, blows the air into the furnace.
Math, art, English.
So this is America's first rolling and slitting mill.
And history.
There we go, my metal's hot enough. This is called a Hardy. What kind of simple machine is this? Wedge.
Students use the latest technology tools to study the country's early innovations.
And how's that, a good looking nail? You guys are too easy to please.
To earn the right to go on the field trip, students spend weeks accomplishing various tasks to get their passports stamped.
All of those stamps are based on our state standards, from writing assignments to design assignments. And as they finish the assignment, the passport is stamped.
All of the assignments involve hands-on activities, from creating an outfit for a rock person
It looks like shiny metal.
to studying rocks and minerals, which also involves internet research.
Chemical composition with an organized structure of a natural and organic origin.
Technology specialist Bob Simpson helped the 5th grade team integrate technology on the project.
Well, the teachers have done all the really good research and constructed the structure of how the students are going to navigate through that unit. And ultimately what that does is it empowers the students to make decisions. So when they're researching rocks and minerals, they get to pick which website they want to go to select their rock or mineral. So go ahead and click on our internet browser.
Students also access the web to study the history of the ironworks. The Saugus unit site also features a parent page that is translated into several languages.
Over here on the axe.
We've had about 75 different languages spoken in this community. So you can imagine what that brings to the table every day. But this kind of cooperative work environment, teachers and students, supersedes that. And working with the computer, working with a partner, going on the field trip, those things are the intangibles that bring this whole project to life and can reach kids that you may never be able to reach in other ways.
This is a picture and right here is a caption.
Okay, your mission is to write a descriptive caption for the pictures you took today.
With digital cameras the school received as part of a technology grant, students add their field trip photos to an Ironworks wiki.
Let's get these pictures into your laptops. So connect your cable to your...
We've seen lots of intrinsic learning. I think the kids own what they've learned. They're very proud of their work. They can talk about their work. And they share much more.
Okay, do you like the other one too? Yeah.
They're learning through the technology, definitely, and with the technology. And they're able to sort of publish themselves at a level that we haven't been able to do before.
Wait, what's that? I don't know, I think you took that.
The integration of various subjects in one project also seems to work.
If you're like in different classes, you sometimes forget because your mind's on one class and then you have to be focused on another class. But when it's all together, you could just focus on one thing because it's all the same.
The circumference of the circle. So when you measure around...
The most exciting hands-on activity is a competition to build the most efficient styrofoam water wheel.
1/16 of an inch. I mean, we're talking maybe 2 millimeters.
As part of a team of more than a dozen teachers and mentors on the project, Earl Fitzpatrick runs the school's tech lab.
The Technology Education Lab is a place where the students can come into the room, actually physically construct a project. It gives them ownership. They built it, they'll test it, and in this case, we'll have not only learned about the water wheel, but they learned about all the tools and machines that it takes to produce a working prototype, the steps in the design process, and whether it succeeds or fails, they can come back and rebuild it to make it a success. And they can actually test it to see if it works and compare their work against other students. It's almost self-grading. 250 grams plus 1,000 grams. There's no need to grade the project. I mean, you put it on the test stand and see how much it lifts, and the kids can know, hey, I made a good effort and my water wheel is efficient. I've achieved the goal.
Whether they finish first or last, the teams are encouraged to learn from their efforts.
All right, looking at where the water's spilling out and how the wheel is operating right now, what might you change about it? So bigger cups. So why would you add bigger cups?
So there can be more water.
Graduate engineering student Andy Mueller from nearby Tufts University guides them through the redesign process.
This is exactly what engineers do. You don't know how something is going to operate until you build it and test it until failure. Now you know that there's a lot of water spilling out the side of this. You don't really know what you want to do. If you can see someone that's excited about anything, it helps the kids out. They maybe say, well, if he's that excited about engineering, you can get the kids excited about it, and maybe they'll want to go into engineering.
Their water wheels seem far more advanced than the first year. Where did that come from?
Redesign is also part of the process for the teaching team that created the Ironworks project in 2002.
We had time in the shop. Then the two fifth-grade science teachers were very flexible. I mean, to the point where we were on the phone up and downstairs, shuttling students up and down so that they could re-glue. They had time to decorate. They had time to make last-minute adjustments, things that we didn't have before. It adds a component. That technology component makes a big difference.
Buoyed by the success of the Ironworks project, the team tackled another project.
So today we're going to look at pictures of animals, and we're going to make predictions about the biomes that they live in based on all of the work that you've done to date.
As part of a second-year HP technology grant, the fifth-grade team mentored fourth-grade teachers in developing the biome unit.
And then you ask the question, so it's 3 different ways.
Are you going to bring me at least up to here?
Yeah.
The project started with a web quest, which led to students designing PowerPoint presentations of a particular biome.
All right, take a look. Slide looks really good. Climograph looks good.
Information for the PowerPoint presentations came from internet research.
Who can tell me what a herbivore is? It's just been a totally wonderful experience. They actually are looking forward to something for a change. I think it's just hands-on, and they don't have to listen to my voice droning on, and they're discovering things on their own. It's just amazing some of the questions that have come up from their own discoveries instead of me feeding all the information to them. I think that's the biggest piece.
It's related to the wolverines, minks, and weasels.
At the end of the unit, they were challenged to justify why a certain animal might live in a given biome.
So using your remotes, make sure that you select a biome.
And their answers were tabulated instantly with a student response system.
I chose the temperature deciduous forest because there's lots of rodents there.
Okay. We wanted to keep that idea of inquiry-based. So it enabled the students to kind of start that type of learning, which is a stretch for a lot of kids because they are used to open the book, read the chapter, answer the questions. This is different. It's not necessarily a matter of right or wrong. If you can justify it, if you can support your answer, then it's a valuable answer. And the students respond to that quite well, and they remember what it is that they're learning.
Who chose the rainforest?
I chose the rainforest because there are a lot of insects and it eats insects, so it's one of its food sources.
The Biome and Ironworks projects inspired both teachers and students, and their test scores rose well above other fifth graders in the district.
I took that picture.
There's a lot of life lessons to be learned by physical, hands-on projects, whether it be a science experiment, a tech ed experiment. You know, they learn leadership roles, they learn how to get along, how to cooperate, and it's good for everyone. Here we go!
You know, often you don't have the chance to show kids that education is real, that there's value to it, that it's out there. And they get a chance to put that all together. Once in a while, the magic happens. And it has happened the last couple of days. And it's happened the last 5 years we've been doing this project.
We have a lift!
For more information on what works in public education, go to edutopia.org.